Hi everyone. I promised I would help you with the first problem on the worksheet for this week, in which we're dealing with a cardioid given by this polar equation, 2 minus 2 cosine theta is r. And we would like to find the equation of the tangent line when theta equals pi over 2. Pi over 2 is pointing straight up, so that would indicate the tangent line at approximately this point, which, assuming I drew this correctly, is something like that. So let's find the equation of that tangent line. Step 0, I'll say, is recalling the formula, which you can memorize, or you can say, okay, well, dy d theta over dx d theta would give me dy dx, because it's sort of like the d thetas cancel. But then I would need to think about y as a function of theta and x as a function of theta to be able to differentiate these things. We definitely know that y is r times sine of theta, and x is r times cosine of theta. And given the fact that r is written as a function of theta as well, I could think of r as a function of theta. And then to find dy d theta and dx d theta, we could just differentiate these things. Right? This will give me the general form, and then we can plug in our actual equation. I just want to make sure you guys know how to get this formula without memorizing it. So to differentiate r times sine theta, I need product rule. We'll do derivative of the front function, so r prime times the back, which is sine, plus front times derivative of back. Derivative of sine is cosine. Similarly, for dx d theta, again, derivative of r is r prime times cosine, plus the front times derivative of the back. That would be negative sine, so let me change this to a minus. And then I put it all together, right? dy d theta comes in the numerator, dx d theta goes in the denominator, and we get this big messy formula, which I recommend you to not memorize, because it's going to be way too easy to lose track of where the sines and cosines go and where there's a minus sign and all that. As for me, I just rederive it every time. Even if that's a little time consuming, it means I should get it right. Okay, so that's the general form. I call that step 0 because you sort of need that to proceed, but you could also memorize it if you prefer. Then calculating dy dx for our problem, all I would need to know is what r prime is. Notice I wrote r primes here instead of r primes as a function of theta, just to save space. But we know it's a function of theta. R prime would be, okay, derivative of 2 is 0. Derivative of cosine is negative sine. So that would be negative 2 sine theta. So positive 2 sine theta. And I can just go ahead and plug that whole mess in. For r prime, we just figured that out. 2 sine theta. And then I have another sine theta, so let's call that sine squared. Plus r. R was given to us originally as 2 minus 2 cosine theta times another cosine theta. I'll just stick that outside here. Similar story down below. R prime is 2 sine theta times cosine theta minus r is again 2 minus 2 cosine theta times sine theta. Make sure that all fits in the fraction. Okay, huge. If you want to simplify this a bit, you can. One thing you could notice is there's actually a factor of 2 on everything. I guess you should be careful with those, but you can sort of cancel all the 2's and be left with something that should look like sine squared. Let's actually distribute this. That would have been plus cosine theta, because that 2 will go away once I cancel all the 2's, minus cosine squared theta over, again, let's get rid of all the 2's down here. So I'll get, well, this is kind of interesting, I suppose. we'll have a sine times a cosine, and we'll have another sine times a cosine. So even though I cancel the 2's, I actually have 2 of those. So I'll get 2 sine cosine. And then, whoops, we'll get minus 2 times sine theta. But again, I'm canceling all the 2's, so that's just minus sine theta. Okay, and then if you want to use trig identities, you can. I suppose sine squared minus cosine squared is negative cosine 2 theta, I think. So I'll keep the cosine, then it'll be minus cosine of 2 theta. 2 sine cosine, that's sine of 2 theta. And then still minus sine of theta. Okay, that's as far as I want to simplify. Really, we need, so this is the general derivative for any point theta. We know we want the derivative at theta equals pi over 2, so I'll just plug in pi over 2. Cosine of 2 theta would then be cosine of pi for that term. Similarly, down here, you'd get sine of 2 theta is sine of pi minus sine of theta, so sine of pi over 2. And, okay, cosine of pi over 2 should be 0. Cosine of pi should be negative 1. Sine of pi is 0. And then sine of pi over 2 is 1. So I should get negative 1 for the slope. That's nice. If you look back up at the graph, yeah, looks like I got the slope approximately correct when I sketched this thing. I sketched it in Desmos beforehand. It's kind of hard to sketch polar plots without just plugging in a bunch of points. But anyway, that's our slope. If we want to use point slope form for the equation of a tangent line, we also need a point on the curve, you know, where we're looking at that tangent line. Basically, we need to know what this point is, x0, y0. So what do we know? We know theta is pi over 2, and we know that r is 2 minus 2 cosine theta. That's the equation for the cardioid that was given to us, 2 minus 2 cosine theta. So just plug that in here, and r would be 2 minus 2 cosine pi over 2. Again, cosine of pi over 2 is 0, so this should just be 2. So in polar form, the point is r comma theta, 2 comma pi over 2. This is r, this is theta. But we would prefer it in Cartesian, or rectangular coordinates, whatever terminology you prefer. That's where we have x comma y. How do we do that? Same idea, just remember x is r cosine theta, y is r sine theta. We just figured out r is 2. So this is 2 cosine of theta is pi over 2. Similarly, y is r sine theta, so I just plug r and theta in. Cosine of pi over 2, again, that's 0. Sine of pi over 2 is 1. So our point should be 0, comma 2. That should be basically all we need. Point slope form is y equals y0 plus the slope. I'll write it using the notation we've been using this whole time, x minus x0. If you prefer, you know, you could write y minus y0 equals m times x minus x0 or something, if that looks more familiar. And then, you know, m is just the slope of the curve at theta equals pi over 2. But we'll stick with that notation. Y0 we just figured out. Maybe I'll actually label those x0 and y0. Y0 was 2. The slope was actually negative 1. X minus x0 was 0. So this is actually a pretty simple equation of a line, it's just 2 minus x. Y is 2 minus x. And sure enough, again, if you go and plot in Desmos, it is a line with slope -1 and y-intercept 2. Cool. So that's everything. I hope that was helpful. Make sure to upload your solution by 11:59 tonight, and I'll see you next week.